Hello and welcome back to the Tied Up video demonstrations of basic physics concepts. In this video, we discuss about the concept speed. Speed describes how fast an object moving at a given instant. For example, if your speedometer in the dashboard indicates 100 miles per hour, that means that the speed of your car, at that instant of time is 100 miles per hour. If you drive your car at this same constant speed of 100 miles per hour, you will cover a distance of 100 miles in 1 hour. If you drive the car at the same speed for 2 hours, you will cover 200 miles. At the same speed, a 3-hour drive leads to 300 miles of distance. Note that, in each of these cases, if you divide the distance traveled to the time taken for travel, the ratio will be a constant, and it will be equal to the speed of your car. Note that, in this demonstration, we assume that the car is moving at a constant or uniform speed. But in practice, no one really travel at constant speeds continuously. Imagine that you are driving your car from Auburn to Atlanta. You must have noticed different speedometer reading at different instances of your travel. That means, your speed varies as and when you push the accelerator or brakes. If the indicated speed is higher, then the amount of distance you travel in unit time will be more. On the other side, if the indicator shows a lower speed, the distance you move will be less in unit amount of time. Now let us consider motion of the car when the speed is not uniform. That means the speed is changing with respect to time and distance. Therefore, the distance traveled may be changing in every unit amount of time. In that case, speed at a given short interval of time can be measured by measuring the distance traveled in that smaller interval of time, and divide this with the time interval considered. We can see that the speed at this short interval of time is the slope of the line AB, in the distance-time graphical representation of motion. Finally, we can think about speed at a given instant of time t1. For this, consider the time interval smaller and smaller. In the limit, the ratio of distance traveled in a differential time period will become the differential coefficient of the curve at that location. Finally, if distance traveled is represented as a function y, where time is an independent variable, then the speed at a given instant t equals t1 will be d by dt at t equals t1. Many thanks to Sir Isaac Newton for inventing calculus. Thank you for listening.